Hi, everyone. Okay, so we want to apply life cycle assessment in the circular economy context. In order to do this, we need a deep understanding of life cycle assessment. Today, I've invited Reinhard Heyungs, Associate Professor in Quantitative Methods, to give us a bit more detail on life cycle assessment and help us to understand a little bit more deeply what the tool was intended to do in the first place and how we can use it perhaps in the circular economy context. Okay, so welcome to Wageningen University.
Thank you.
It's not the first time that you've been here before.
But it's a pleasure anyhow.
Nevertheless,
Yep.
It's our pleasure to have you here. And let's start with your definition of life cycle assessment. What does the term life cycle assessment mean to you?
Well, that's a very good question because there's a lot of, misunderstanding, I think. Most important thing is, of course, it's analysis, that's one thing. It's not based on ideology, on the thing that recycling is per se good or not. So it's analysis, tries to be objective, scientific, etc. And of course, what about the life cycle? And what's a life cycle? Well, that's a little bit weird word in some sense because it's not necessarily a cycle. And of course, that's where the discussion with the circular economy pops in at some point. Typically, a product starts at some point, and we say that's the cradle of the product, which means basically the raw materials mining, and then it continues until manufacturing, use, maintenance, disposing, which is the grave. And of course, there can be all sorts of variations, and circular economy may be one, but that's typically what we say is the life cycle. So the life cycle analysis is about that. And then specifically, it's about the environmental impacts of that. Of course, you can extend to economic impacts and to social impacts, but today I think we keep it to environmental impacts.
Okay.
So that's my definition for at least for today.
Excellent,
Yeah.
excellent. So just coming back to, since you've been involved in life cycle assessment since the very beginning, I wonder if you could give us some idea of how this concept came about. How did it all start? Where does LCA come from originally?
Yeah, where it came from, I think, is a discussion that had been going on about some classic examples are the baby diapers, the coffee cups, like we have one here, and some more plastic bags versus paper bags. These are some classic examples, and people thought, well, we need to know what's better, plastic coffee cup or paper, or perhaps China work. And then they came about, well, there's advantages of all different systems, and we have somehow to make a trade-off, and making trade-off means doing the numbers right, so doing a quantitative analysis about that. And then they started to work out some details about impacts of paper production, details about impacts of plastic production, etc., and then trying to quantify that. And that's where it all grew around. And then gradually, whenever a method was developed at some point, people started, well, now we have it, we can also try to apply for more complicated systems like cars and like waste treatment facilities and, well, maybe circular economy.
Okay, great. And that's where we are now, some 25 years later.
Right.
And so just to recap for the students, circular economy, essentially, at least what it means to me, is closing material loops. And a large part of this, or the reason for doing this, is to preserve the environment or avoid environmental damage. It seems like life cycle assessment would be the perfect tool to assess this. But then the question is, how do we fit life cycle assessment into this circular economy context? Are there things that we need to be careful of? Are there things that we need to bear in mind when we talk about closing material loops and using life cycle assessment?
Yes, it's a very good question, because there's many people who feel that somehow, well, this is about quantitative, it's about environmental impacts, and it's about, well, products and stuff. So LCA is the way to go forward. But at the same time, LCA is about a product, and the circular economy is not just a product or a collection of products. It's really a whole fabric of things that are interrelated.
Yes.
So not necessarily the product LCA, like we sometimes use that word to indicate very clearly that it's about products.
Yes.
The product LCA is not necessarily appropriate for the circular economy, and you really have to fit, to think in a very clear way about what its limitations are, how you can adapt it if needed, and all the results you get, to what extent they are applicable to the questions that we have in mind and where the boundaries of these answers are. So that's a very good question, and I don't have answers to all your questions in that sense. I mean, it's work in progress, but the main thing is about not just do it. That's not the way forward. I mean, don't use the product LCA and then apply it to circular economy system and then ready. That's not the way. So we always think about, well, was this okay? So maybe you have some specific question then about that.
Well, okay, so
Yeah.
so the first thing I see people start to talk about in the scientific literature is perhaps allocation. So that would
Right.
be a potential solution between multifunctional processes. So that's one thing we could maybe do to adjust the product LCA a little bit. The other solution could be a consequential life cycle assessment, which
Right.
answers a different question, but
Yep.
it's a more sort of, at least the way it's presented, is a sort of systems approach, where you could look at an entire system, not just a product.
Yep.
Is there anything that we need to be careful if with regard to either the allocation or the consequential approach? And does it make sense to make such a distinction?
Yeah. I think it's even a wider question because it's
Okay.
also about system boundaries, also about functional units. So many of the things that occur in the LCA procedure, I think very relevant if you want to make it broader. I think we're in that process of making it broader. Well, to start with one thing, LCA is not about products. LCA is still about systems already,
Okay.
because it's a product system. I mean, it's about the product, but also about the production, manufacture, the mining, disposing, etc. So it's already a system. But nevertheless, it's only a partial system. It's cut out of the complete economy. It's not about the complete economy. It's only about the supply chain, etc. As far as relevant to this specific product. So it's about the system, but not about the full system. And now we're trying to make it a little bit broader. And it means that all things you have to decide on in doing a product LCA need to be, well, reconsidered. That start, I think, with functional unit. It goes on to system boundaries, to the question about consequential or attribution LCA, about allocation, etc. And I'm fine to having all of these discussed separately. Maybe we should do that just one by one, if you like that.
Yes,
Yeah?
sure.
We'll do that. Okay, maybe then start with, let's say, maybe start with the system boundary thing.
Okay.
Yeah. So typically, if you do a classical product, you have a very clearly demarcated system boundary. It means, okay, you have to think about if you take a paper cup, well, you need to grow trees in a forest, and well, it means that there it starts. And of course, it's a little bit difficult to find the start exactly. I mean, where the trees, is that nature or is it an economic production system? You may still a little bit debate about if it's part of the economy or if it's part of nature or perhaps some hybrid thing in between. Yeah. But at least such discussions make a difference in if you see, for instance, if you see the land use of a forest as a competitive land use, so as a sort of, well, impact that we are using scarce resource of land, or that you see it, well, this is a great natural asset, so we should be happy that it's there. Yeah. And so is it an impact using land, or is it fantastic? Yeah. I'm not going to judge on that, but at least that's one of the examples of where you have to make a decision. And that type of decisions you will have everywhere. Cutting out a system for a specific product like this one of the total economy is, well, it's not completely straightforward, but it's sort of straightforward. Some nasty details, but fine for that. If you're going to think about a complete economy, a circular economy, which is a really economy-wide thing, it's not about a specific product, but about the total thing, well, there's no need to cut out anything. No. So maybe that's easier even to think about system boundaries in that sense. Of course, there's still some boundaries in terms of that you still think about, for instance, about just the Netherlands or about the EU, about the world. So what is the scale you're talking about? So there are some boundaries, what to do with the past or the future. So some temporal boundaries as well. Okay, we have to think about that. But basically, it's a little bit simpler. But now start to think about the thing about functional units. Yes. So typically, if you consider a product, you have to, if you want to quantify, it just means you have to define how much of a product. If you say, what is the impact of coffee cups? Well, there's no answer, because you have to say, okay, per coffee cup or per 1,000 coffee cups. I mean, you can think about it, and that's where the functional unit comes in. If you start to think about a complete economy, what is the scale? What's the quantitative basis of that? I think the most natural thing is full scale, which is the total economy as it is working now, or perhaps in 2020, something like that. So that means basically, I think choices about functional unit for a complete system, circular economy is perhaps easier even
Yeah.
than for a product. But now start to think, why are we doing this? Because we want typically to compare. So typically you want to compare one type of coffee cup with another type of coffee cup, which I don't have here.
Yeah.
What about the circular economy? Is there a comparison involved or not? Well, maybe you have an answer, but there's no answer on itself. So you do want to analyze the circularity of the economy as it is now, or do we have different, let's say, policy measures that can be implemented, and we want to compare which one lead to the right direction and which one don't. So let's say comparing a couple of possible future scenarios, that might be another question. Oh. Okay, you name it. There's no right or wrong here. You have a specific purpose for your question, and then you determine what's going to happen.
Okay. So if you...
We want to go to allocation, but we can do it a little bit later.
No,
because
no,
that's more
fine.
okay,
Yes,
allocation. So allocation. Where does it end up? Well, we're speaking about system boundaries. So typically you want to demarcate for a specific product, okay, how's the life cycle cut out of the total economy? Well, then let's say, take the simple example that we have some plastic product made of PVC. Part of PVC is chlorine, so you need to produce chlorine. But we know that if you produce chlorine from sodium chloride, you end up with some, soda as well. Okay, that's a case of co-production or joint production, which means that part of the impacts of this industrial process of sodium chloride electrolysis may be attributed to the chlorine part, and some may be attributed to the sodium part. Or, what to do with that? There's no fixed answer to that, but you have to make a choice at least, and to report it in a transparent way, maybe do some sensitivity analysis about that. So there's different ways to go forward. And whenever we start to think about a circular economy, we also need to reconsider what's going to happen there. Basically, if you cut out less, you have less problems in making decisions about system boundaries, allocation, etc.
Yes.
And I think the same applies even to circular economy. So in the end, I think my conclusion about this is maybe it's much easier for circular economy, for economy-wide systems, than for the product level. So maybe it's perfect. But at least don't, just with the eyes closed, apply the standard methods that have been developed in the context of product LCA, because they may not be applicable.
Yes, indeed. Great, that's excellent. And this leads me to the next question, which I think is important and is perhaps at the core of this. I've told the students already in one of our previous lectures about life cycle assessment being a linear approach. Okay. What does that mean? As I understand it, it's linear perhaps in two ways. Maybe you can tell me what you think about this.
That's a good question. I didn't see this lecture from yours. So I'm curious what you mean by that, because there's a lot of confusion always about such terms, and if you don't define them, basically they don't mean anything, right?
Indeed.
So I know there's some people, linear, it can mean that just a straight line. You say there's no branching, something like that. You say, okay, you start with some raw materials, and then you go to products, and then to waste, etc., and there's a linear thing. So that's linear. You can also understand it in a more, let's say, mathematical, quantitative way, which means that let's say, the impacts of 1,000 coffee cups is just multiplication of 1,000 of the impacts of one coffee cup. That's also a linearity, but in a very different way. Yeah. And depending on what you have in mind, or maybe you have both in mind, we're on the same side.
Yes.
So, and then maybe it's just a property, or it's an advantage, or it's a restriction. I don't know. It means, what are you speaking about?
I'm speaking about the second point now, specifically.
The quantitative thing.
Indeed. So you can scale it linearly.
You can scale it linearly.
What is the advantage of that? Why is that?
Yeah, and that's an interesting thing. Also, because we didn't so far, you briefly mentioned it, but I didn't go yet into that, the issue about attributional and consequential LCA. Maybe I have to go a little bit into that topic a little bit, because let's first go to the attributional LCA. If you want to say there's a complete system as it is working now, the total economy, and it has certain impacts right now as they are there. And then we want to say, okay, part of these impacts are for coffee cups, and part of the impacts are for cars, and part of these impacts are for pork. So we really go to allocate or to apportion, to do an attributional thing about for the different products that are part of our consumption basket, to put them on those different products. Okay, that will work fine, but if you start from this, from let's say a mathematical perspective, well, I don't say it's a mathematical perspective, a scientific perspective, which is different. What means science is being basically able to validate in a real context.
Yes.
And now take a very simple example. We go together at some place by car, and at the end of the trip, we say, okay, shall we just split the cost for the gas? Okay, we say that sounds fair. But then my question is, yeah, my body weight is different from yours, so perhaps we pay a different amount.
Yeah.
Or say, oh, you were driving, so you will pay less. So the different principles of doing that, and all of them make sense, but neither of them is true or false.
Yeah.
As long as it adds up to 100%, it's good.
Yeah.
And the same, I think, is true for the attributional LCA. If we say, okay, these are the total impact, and now we're going to apportion this to the different products, there are different ways to do that.
Yeah.
As long as it adds up to 100%. And then you get all the discussion about how to do this and the different schools of doing this. And I think one very great way of doing this is going to linearity. Like we say, okay, linearity, let's say in terms of that if you're driving a car with 3 persons, okay, each of them pays 1/3. Well, that makes sense. That's a sort of linear attribution. And we basically do the same thing typically as a default in the LCA world.
Okay.
So there's linear is really built in, and that makes sense. Of course, you can always debate that it's not completely fair because one person was more heavy than another person, so maybe it's not completely true. But there is no point about making things about true or not true, because in the end, if it adds up to 100%, it's true.
Indeed.
And in detail, anything goes. So it's about fair, it's about reasonable, it's giving the right incentives. And then within that, there's lots of space still. Linearity is then one solution to that, and that means that really having, well, basically it means that let's say the LCA of a cup and the LCA of 1 unit of coffee together is the same as the LCA of a cup of coffee. You can add it up. It makes sense to do so, and then you get a really this fair type of 100% type of thing. So great. So for attributional, now we move to consequential. What is that about? Well, we have a system. The system as it's running now, today in the world. And now say, well, I would like to have some coffee. Can you get something for me? And then you basically study the question, okay, the world as it is will continue as it was running, but with one change only, and that is 1 extra coffee. And this total system will have a little bit of extra impact. And then you say, okay, this small extra impact will be caused by this 1 extra unit of consumption.
Is that realistic?
And that's not realistic, of course not. But we in science we used to do also things which are not realistic. I mean, we also trying to think about what happens if Jupiter was not there, and then you can think about how the solar system would behave. I mean, it's not realistic, but you can do calculations about it. And that is the same time we know the laws of Newton, so you can do that. And I think here the same is true. We know a little bit about chemistry, we know about logistics, we know about everything. And you can imagine, okay, now with the system as it is, 1 extra coffee means a little bit extra water, a little bit extra this, a little bit that, etc. And in the end, it will build up to this. And this will be the extra impacts associated with it. You can model it at least. Not necessarily in a linear way. That's the important thing. It means that if you ask now, please give me 2 coffee. Yeah, maybe you don't have twice this extra impact, but you have that economy of scale or this economy of scale. I don't know. We can see that. But at least it's not just having a model. Basically, you might be able to validate it, to verify it. In practice, it might be difficult or impossible even, but it's scientific. And that's different from the attributional thing where you say, okay, as long as it's fair, it's fine. There's nothing about fair in the consequential. It's really about basically doing the experiment.
Okay.
In practice, we can't. We do the models. And then you come to this issue, well, these models basically should not be linear because we know the reality is not linear. Of course, for practical approximations, we may rely on linear models that work good enough under some conditions, might be fine. So in that sense, I think linearity is not so simple yes or no.
Okay.
I think it depends on context, depends on scale.
Yeah.
If I ask for 1 million cups of coffee, I think extra cups. We're running out of the linearity, for sure.
Yes.
You need an extra truck, not just have a little bit extra cargo.
Yeah.
And then it's a really different story.
Okay.
So I think if that makes sense,
That's
is
clear.
answer. Yeah.
Excellent.
Okay. Yep.
And this brings us to one interesting question about context.
Right.
Within the literature around circular economy, there's this idea that you should rank your, let's say, waste disposal alternatives, or you should there is a sort of hierarchy to how you manage your materials. So, for example, it's preferable to reuse something.
Mm-hmm.
It's preferable to we prefer to reuse it than to recycle it. And recycling is preferable to incineration, for example. So there's a sort of hierarchy between material management options. When we try to apply life cycle assessment to this, would that necessarily prove that this hierarchy is correct, or would it be context specific?
Well, I don't know what will happen, but I think it will be context specific. And I can easily imagine that if you're living on a very small island state in the middle of the Pacific, well, making a big plastic separation facility over there will not really be a good idea. But perhaps in a very densely populated big country, it's a different story.
Sure.
So all these things I think are highly dependent on the scale, and also I think that's where indeed this linearity, non-linearity matters a lot, because it's really about the background scale and the background levels of all the different things that are happening. And then in certain cases, well, you may be able to validate, to prove such rule of thumb, such waste hierarchies and material hierarchies. And in other cases, well, there may be at least be exceptions, and how important the exceptions are, or if they will dominate the picture, I don't know. But there will be certainly some cases where you have exceptions,
Sure.
for sure. And of course, that's you have to keep in mind. This is all about a rule of thumb. In many cases, in policy, we need to make decisions, although we don't know exactly what's going to happen, and we can't find it out for all situations. Compare that to, let's say, a situation that we have a road, and you want to have a speed limit. We know there's just a speed limit in law, which says, okay, this is the maximum speed. And of course, you can consider that, well, on this specific mile, it might be just 2 miles per hour faster, and this specific mile might be a little bit slower. But, well, that will be a completely unmanageable situation, so we need to have a thing that works out fine in most cases. And that's, although in specific cases, you might prove that it's not correct. Mm. And as long as we're in a situation that there's so much not yet clear, and we have no good methodology, not good data, no good computer systems to do specific calculations for, let's say, waste hierarchy, it makes sense to rely on rules of thumb that are sort of good on the average. And if you have evidence that in specific cases another situation works better, well, of course we go to that. Even if it contradicts the rule in that specific case, the rule still may be valid in general.
Yeah. Great. I think that concludes our discussion.
Right.
Thank you very much for your insights.
Thank you.
This has been excellent, really, and given the students a little bit of a deeper understanding of what this is all about and the complexity underneath life cycle assessment. Anyway, so goodbye for now. See you next time.